recently completed one project for Bharat Oman Refineries Limited in Madhya Pradesh in India. So they had got 170 heat exchangers. Okay, we modeled the entire cooling water system for their refinery. And first step was to establish the existing system, right? Then what is the problem that they have got? And once we have studied the problem, once we have found out the problem, then comes the solution. Okay, remedy part, right? So in this case, what you have done, you have found out, okay, the problem is there. That is because of pressure difference is there. Pressure differential is not same in each of these three loops. Okay, now the problem you know, right? So what is the solution?
We should throttle the cooling water flow to the first one.
Okay.
We have
Throttling
to
usually is done at the
reduce the
downstream,
line size
not
after
the substance.
each branch.
But yes, what you are saying, ma'am, is correct. That is one of the solutions. So we'll have globe wall, manual globe wall at say line number 20, then line 21 and line 22. Okay, so that is one of the solution. Any other solution?
Instead of connecting at T number 15, we can connect to second heat exchanger that line.
Okay, so you are saying that from here we need to connect to here.
Yes.
Okay, so will that solve the problem?
Equal distribution will be there.
It will reduce the difference anyway.
Yeah, but will it solve the problem? You're not supposed to reduce the problem. You're supposed to solve the problem. Will it solve the problem? Yes, no, Ajay?
I should think so.
No, it won't solve the problem. So that's why this is not the solution we need to.
We put the control valve.
We can. So what ma'am has said, using globe wall, she had suggested the cheaper option. You are suggesting expensive option, but yes, both are the options. Dr. Joseph, you are saying something?
Yes. 30 years ago, in a problem like that, we use restriction orifice.
Yes.
Because the people in the plant could, but they don't have time to adjust ball valve. So we decided to put restriction orifice.
Yes. So that is yes. So instead of any flow control wall or manual globe wall, so these three lines could have restriction orifice, right? So we'll simulate that. But any other solutions that you might think of? So we're getting less flow in these two segments, right? So why don't we have booster pump for exchanger 2, exchanger 3? So it will suck more flow or excess flow from first loop and give it to the second and third. Will it solve the problem?
Yeah, different diameter of the piping.
But it's not the standard cooling tower systems. Cooling tower system does not have booster pump like in the refinery. You know where we have cooling towers that I'm very familiar with. Apart from the main pumps, there are no other pumps.
No, booster pumps are. It's not uncommon. Booster pumps are also there. Let us say some at remote location there is some the cooling water requirement is there, and you don't want to have a separate cooling tower and cooling water system only for that particular system. So you can always have a booster pump, okay, which is connected to the main cooling tower or from the header. Yes, but booster pump will solve the problem, but it will be expensive. That's why we will not go ahead with that. Dr. Joseph was telling you can play with the pipe diameter. So here we have got 5-inch pipe. It will have some delta P. Okay, if I go for say 8-inch pipe, so there will be some less delta P so that it will push a little more flow. But again, it will be expensive option. So that's why we will not go ahead with that, right? Yes. So let us proceed with putting one restriction orifice in the outlet. But before we do that, let us see this number. What is the velocity in the pump suction and pump discharge? Okay, so 12-inch suction and 8-inch discharge, pump discharge. Is it adequate, acceptable? It is, right? So what is the line setting criteria for centrifugal pump suction and discharge, Ajay?
Typical velocity shall be 1 meter per second.
Okay, for
The
pump
suction.
suction,
Discharge, it should be 2.7.
2.7. Very good. So we are close to that number. All right. So 12-inch suction and 8-inch discharge is acceptable, right? Okay. Now let us put one restriction orifice. So where to get it from? So it is available here. Size change. Okay. So there are different options. We'll go for thin, sharp, edged orifice. Then somewhere in the middle, you need to click. Then here also, and then here also. So once you have provided all three orifices, you can click on this selector. Right? Please select all the orifices.
Which
In the size change, first one.
Okay. They all selected.
Yes, selected, then automatically size, you can make it on. Make it on. So you're going to size for flow. So what is the flow rate you need through each orifice? 100.
yes.
All right, then properties on flow sheet will make it show.
Do I show it?
Yes,
Yeah.
show.
Mm.
Sir,
Yes, sir.
I'm actually not able to simulate the first part only, like the heat exchanger flow is not coming out to be correct.
Okay. Can you share
Yes,
the screen? Go to the messages. All right. So it says high pipe velocity. So you have not changed the diameter. It could be a still 2-inch.
Okay, the red pipes only.
Okay. Go to input. Let us see. Yeah. See, I told you it is 2-inch. So first step is also not completed where I had told to use Hazen-Williams for all the pipes.
Yeah, instead of Moody.
Sir, I did for all the pipes I used.
Yeah, but I could see that for this first pipe itself, it was not. Yeah, see, it's moody. And then coefficient also. Just one second, we'll do the other way. Go to edit. Yeah, pipes. So here you see Hazen-Williams. So change it to moody. Okay. And then again change back to Hazen-Williams. And just put 150, type 150. Enter. Again put 100. Enter. Just click somewhere else and check whether the changes are done or not.
Yes, but sir, previously also I did the same way. I put Hazen-Williams and 100. I don't know why it was not picking up.
All right. So this size we can put it 12-inch for the suction side. Select all the pipes in the suction. Yes. So 2-meter length.
12-inch schedule 40.
See, length you can put 10 meters. Okay. Enter again, type 2 meters. Okay. Then this you make it 6-inch schedule 40. Then again change to 12-inch schedule 40. So there is this way, or you can do it one by one. This for schedule 40 first. Have you selected? No. Okay, now again change back to 12-inch schedule 40. Okay, just check whether all the pipes are now okay. Pick one by one. 2-inch, 12-inch, okay. Okay, this is done. In the discharge, 8-inch, 8-inch, just check quickly.
Yes, sir.
All right, run it. So there is one 2-inch I saw.
It's 5-inch. I don't know.
No. The second
Somewhere I saw
exchanger
50
outlet.
meters.
Second exchanger outlet.
Yes, sir. These are also 5-inch. Are they supposed to be 5-inch?
Second exchanger outlet is 2-inch, no? So make it 5-inch.
Okay.
So the pump discharge length is 50 meter.
Pump discharge is first five pipe segment, those are 5 meters. Then other segments in the header are 50 meters. So in his file from pipe number 11, it is 50 meters. All right, we can run it now. Go to messages. Okay, click on that -13 pipe. Where is that pipe? -13. Click on that. What is, go to input. Input. Okay, why it is 50 meters? It should be 10 meters. Okay, check for others also. 10 meter, 5-inch.
5-inch, 10 meter, 5-inch, 10 meter.
All right, give me control.
Given,
Let me
sir.
check one. This is okay. Then pump, we are pushing 300. This is closed. This T I had told to make it on the left side. This pressure drop I set 1 bar, not 1 Pascal. That is the reason I had put this table so that easily we can find out. Right?
Okay.
Make it left. And I had told to use the entire space. Okay, so 1, 2, 3. This should be 1 bar. Then run it. So go to messages. Low pipe velocity, it says what's the problem. What is it? Fixed temperature change? I said ignore it. Again, many other input systems. 10 degrees C, this is okay. Sir, this is not 2-inch. Eight-inch schedule 40. What about this? Eight-inch schedule 40. And the length was 50 meters. This also 50 meters. This is fine. So there is this function here. This one, show flyby. If you select that and just hover over here, okay, you can see the different in, right? 15 degrees C. This one is elevation 2 meters. Okay, elevation is not given. Yeah, it is given. Then the pump data, right? So again, you can calculate. You are getting 136, 86, and 77. All right, so I saved it.
I also didn't get the answers.
Okay, so did you check what are all things I
have to
did?
add.
Yes, please
Yes,
add.
sir, but I think I made some mistake with the pump one, sir. Other things are correct.
Okay, please share your screen, ma'am.
It will be in size changes. Yeah.
But what is next?
This doesn't seem to be connected, ma'am. What is this? Okay, and this pump should be inactive or off, right? And this was supposed to be on, and this one also on. This is correct. This also doesn't seem to be connected. Or is it? Your orifice is very close to that outlet. You need to occupy the entire space. There is a lot of space, right, in the model. So we're getting zero flow. Why is that? The orifice data, we are not given it yet full. All right, so this is fine. We need to provide the, ma'am, you are not connected it.
T number 27. Red dot should be on red.
Mm-hmm. All right, till this part, everybody has completed.
So shall I share screen? I have a doubt.
1 second. Ma'am, you need to provide the this table also. So friction loss is 1, and what else was there?
Flow, the other one was flow.
Flow we are given for the exchanger, so not required. We make it left. All right. We need to provide the pump core data, so it's okay if it doesn't run.